All right, in this video, we're going to be looking at some solutions questions. In this first one, we got a multiple choice. If 200 milliliters of 0.6 molar MgCl2 is added to 400 milliliters of distilled water, what is the concentration of the Mg plus in the resulting solution? Assume volumes are additive. Okay, so here we are doing a dilution problem, and every time we do dilution, we voom. M1 V1 is equal to M2 V2. Okay. We know the original molarity was 0.6 molar, and we had 200 milliliters of it. And the second molarity we are looking for, that's what we're solving for, and we added 400 milliliters to it. So that means the new volume is going to be 1,000 milliliters. That's volume 200 plus 400 is 600 milliliters, 600 milliliters. Now, I know molarity is calculated in terms of liters, but since we are just doing voom and we keep the milliliters constant, we are going to have the correct molarity here, so we'll be just fine keeping it this way. Both those milliliters will cancel each other out. So then we take 0.6 times 200, and we'll have to divide both sides by 600, and we should get the new molarity concentration. So we'll take 0.6 times 200 and divide it by 600. And we get a molarity of 0.2 molar. Okay. Remember, this is the original concentrations and volumes, and this is the new concentrations and volumes. Since we added 400 milliliters of water, it went up to 600 milliliters of water when we were solving. Okay. Look at this next question. What volume of a 0.5 molar stock solution in milliliters would be required to prepare 100 milliliters of 0.05 molar KiO3? So once again, this is anything that dilutes or prepares a solution, we are going to use voom. So M1 V1 is equal to M2 V2. In this case, we are looking for V1. So we do have M1, that's 0.5 molar, that's the stock solution. We don't know what this is, so we'll leave that as V1. And that's equal to 0.05 molar, 0 molar KiO3 times 100 milliliters. Once again, I'm going to leave this in milliliters since I'm looking for milliliters as my answer. So I can definitely just leave it right there. Okay, to solve it, I'm going to divide both sides by 0.5 molar. Okay, by doing that, 0.5 molar. By doing that, this cancels, and I will get my answer V1, which 0.05 times 100 divided by 0.5 gets me 10 milliliters. So that would be I need 10 milliliters of stock solution. So what this is trying to say is if I pulled 10 milliliters of the 0.5 stock solution and then I added 90 milliliters of water, I would get a solution, 100 milliliters of it, that has a 0.05 molar concentration. So you need to start with 10 milliliters. Now for this last question. To prepare the diluted solution, the student uses a graduated cylinder to measure the volume of stock solution calculated in part H. So they grabbed this 10 milliliters right here, and then adds it to a 100 milliliter volumetric flask, followed by the addition of distilled water. If the student then fills the volumetric flask with distilled water, but the bottom of the meniscus is significantly below the 100 milliliter mark, would the resulting solution concentration be greater than, less than, or equal to the intended concentration? So a volumetric flask looks something like this. It's got a round bottom, and it has a single mark right here. It's 100 milliliters in this case. So what they would have done is they added their stock solution of 10 milliliters, and then they try to add the rest with water. Okay, I have green water for no reason particular. Okay, but they're saying they didn't get it to the mark. The mark's right here, but they didn't get there. It's below it. Okay, so they didn't add enough distilled water. So is that going to affect the concentration? Absolutely. It's not going to be equal as intended. The question is the concentration going to be greater than or less than 0.05 molar? That's what they were trying to get to. Okay, and the answer is it's going to be greater than. Okay, you have too much solute to solvent or total solution volume, so you have more moles per liter. You don't have enough volume, so that's going to increase your concentration. So when you justify your answer, talk about how you did not add enough distilled water to the amount of moles of stock solution you have, so you're going to have a greater concentration than your intended concentration of 0.05 as intended here. Okay, that would be a good way to answer that question. So that's it.